A few weeks ago, Arthur, a 74-year-old retired engineer, sat in a living room with the curtains drawn, staring at a stack of unopened mail. A man who once spent his weekends hiking and volunteering at the local library, he now offered only a weary, practiced smile, claiming to enjoy the peace and quiet. On the surface, it appeared to be the ideal picture of a graceful retirement, the very state society encourages after decades of labor. However, this peace functioned as a vacuum. Arthur had not spoken to anyone in 4 days. Since he stopped driving, his world had shrunk until the highlight of his day was the distant sight of a delivery driver. He was not sick by traditional definitions, no fever, no broken bones, yet a physical heaviness permeated his movements, a sense of becoming invisible even to himself. Society conditioned us to believe that as the body ages, the mind naturally dims, yet Arthur's reality was a profound crisis of purpose. He looked at his muted television and whispered that the hardest part was not the pain in his knees, but the feeling that he had finished his part in the story while the credits had not yet started rolling. This moment of raw clarity revealed a massive, silent epidemic. We often assume that reaching the end of a career equates to emotional stability, but the reality is a terrifying state of suspension. This is not merely boredom. It is a fundamental disconnect between human biological reality and the structural reality of modern aging. It is a biological catastrophe. For the vast majority of human history, retirement did not exist. Individuals remained functional, integral parts of the social organism until death. The brain mechanisms driving humans to connect and be useful do not possess an off switch. They do not retire when a job ends. The human brain still runs software designed for the Pleistocene, expecting daily, high-stakes social interaction and utility. Yet it is forced to operate in the silence of a suburban living room. This mismatch causes the biological system to malfunction, triggering alarms that observers misinterpret as slowing down or depression. The body reacts to the loss of its social environment as violently as it would to the loss of oxygen or food. Consider the case of Kenji, a retired engineer in a cluttered Tokyo high-rise. After 40 years of building the infrastructure of a nation, he became a ghost in his own neighborhood. Biologically, Kenji's brain reacted to this isolation with primal intensity. In evolutionary biology, this is recognized as adaptive pain, an aversive biological signal identical in function to hunger, thirst, or physical pain. Hunger signals a need for energy. Pain signals a need to avoid damage. Loneliness signals a mandatory return to the group. In an ancestral environment, isolation was lethal. A solitary human on the savannah was not an apex predator. They were prey. Without a band, there was no access to shared resources and no one to guard against predators during sleep. Natural selection invented a mechanism to make solitude feel intolerable, ensuring humans stayed together for survival. When this alarm rings without resolution, the biological system shifts into a state of chronic threat surveillance. The brain assumes it is in a hostile environment without backup and prepares the body for an imminent attack. This manifests as increased vascular resistance, arteries tightening to pump blood to muscles, leading to chronically high blood pressure. Elevated cortisol keeps the body on high alert, creating systemic inflammation and suppressing the immune system's antiviral response. The body prioritizes short-term defense against a perceived leopard in the bushes over long-term health maintenance. This extends to sleep. Isolated individuals experience micro-awakenings because the brain refuses to enter a deep, restorative state when it believes no one is guarding the cave entrance. This is grounded in hard neuroscience. Researchers at MIT identified specific dopamine neurons in the dorsal raphe nucleus, an ancient part of the brainstem that drives social craving. When stimulated, these neurons trigger a desperate, social-seeking drive identical to the urge for water during dehydration. Sensitivity to isolation is a biological trait, approximately 50% heritable. This spectrum served the species. Guardians with high sensitivity maintained social glue, while explorers with lower sensitivity pushed into new territories. Kenji likely possesses a guardian genotype trapped in an environment demanding explorer resilience. Furthermore, high-status individuals often suffer more from isolation. In animal studies, dominant individuals show the most severe reactions to being alone because they have the most to lose: respect, grooming partners, and resources. For Kenji, the drop-off from a respected engineer to an invisible retiree was a precipitous cliff. His brain registered a catastrophic loss of utility, signaling that he had fallen from the center of the tribe to the dangerous perimeter. This biological need to be useful is exemplified by Margaret, a woman in London who was once the matriarchal glue of her extended family. She embodied the grandmother hypothesis, a vital post-reproductive stage where wisdom and care ensured the survival of the next generation. When her family moved overseas and she transitioned to a senior living community, her psychological utility was severed. She described herself as a useless machine left in a shed. In most species, females die shortly after their fertility declines. Human women, however, live decades past menopause, a period that is genetically silent in terms of direct reproduction. Evolutionary logic suggests these years must have a function: inclusive fitness. Grandmothers ensure the survival of their grandchildren. In hunter-gatherer societies like the Hadza, grandmothers are primary producers, digging for deep, fibrous tubers that nursing mothers and children cannot extract. This calorie surplus allows the mother to stop nursing sooner, resetting her hormonal cycle and shortening the interbirth interval. Grandmothers are the reason humans could out-reproduce other species. They provided a subsidized intergenerational childcare system built into our biology. When Margaret was placed in an environment where her physical needs were met, but her core function was denied, her brain calculated her inclusive fitness potential at 0. In an ancestral context, an individual who consumes but does not produce is a liability to the tribe. The depression she felt was a biological signal of obsolescence. Modern society offers the elderly leisure, bingo, and distraction, yet evolution cares only for essentiality. There is a fundamental distinction between activity and purpose. For a brain wired to ensure the survival of kin, a lack of purpose feels like a death sentence. This neglect is often a passive withdrawal of investment, viewed through the lens of life history theory. This biological framework describes how organisms manage finite energy budgets. Evolution prioritizes reproduction, the only currency that matters in the long run. Consequently, ancient algorithms in the human brain calculate future reproductive value. A strained healthcare system may instinctively prioritize a 20-year-old over a 74-year-old because the former represents future potential while the latter is viewed as a sunk cost. However, the premise that elders are a drain is factually incorrect. Humans are skills-intensive animals who survive through learned behavior. While a 20-year-old has physical strength, they lack the manual, the experience required to navigate droughts, identify medicinal plants, or manage complex social alliances. Elders serve as the external hard drive for the tribe, holding the information capital. They are net producers of competence. When Arthur teaches, he engages in a massive transfer of capital, an evolutionary act that increases the survival odds of the entire group. The tragedy of modern aging lies in treating producers as consumers and resources as patients. Kenji suffers the physical pain of isolation. Margaret suffers the psychological pain of uselessness. Arthur suffers the pain of devaluation. These are symptoms of a structural failure. We have solved the problem of physical survival, keeping the elderly fed and warm, but we have created an environment toxic to their social biology. The biological perimeter of a human being includes the people around them. When social connections are severed, the brain registers it as physical damage. By isolating the elderly, we actively damage their cardiovascular and immune systems. We are breaking the intergenerational lifeline, the transfer of care and wisdom that defined human success for 2 million years. Arthur's metaphor was correct. The credits have not rolled, but the projector has been turned off. The solution is not better medication or entertainment, but reintegration. We must recognize that for a social animal, peace and quiet can be a lethal environment. The greatest damage is not occurring within the cells, but in the severed connections between us.